I'm Emma Takács, a research associate from HUN-REN and I was leading the 5G-SEDAR project. Our consortium has two members, the HUN-REN and MMBIL Ltd, and we have been working closely with the Norwegian facility at the University of Oslo. So in 5G-SEDAR, we try to address two major issues in human-robot collaboration. From the human aspect, that there is a lack of validated and ergonomic assisting options for operators, which can increase their mental workload and can raise safety issues. And from the robot aspect, there are only wired or low bandwidth sensors that can be attached to the robot to collect data, and this excessive wirings can cause issues with the trajectory planning, and it also makes it harder to create an accurate digital twin. So in 5G-SEDAR, we wanted to create a human-centered AR system. This is computer vision and data collected from a novel wireless 5G-enabled sensor platform that can be attached onto the robot, so there are no wires running along the robot arm. We also wanted to test and validate our solution with network measurements and user study. So the AR assistant that we developed is displayed through a HoloLens 2 AR glass that can be worn on the head of the operators. And we are using holograms to guide the operator during the assembly process and show them which part to pick up next for the assembly. And during the disassembly process, we indicate them when it is not safe for them to enter the collaborative workspace, because the robot is also working there at the moment. For the tests and validations, we got really great results. We did detailed performance measurements over UIO's private 5G network, simulating real-world scenario with all kinds of traffic that would happen in real life as well. So we were varying the packet sizes, bandwidth, and different loads. And we reached all of our target values that were possible. During the user studies, we also got really good preliminary results. It was shown that using the AR assistant made the operators make less mistakes during both the assembly and disassembly processes. And also it made them safer, feel them safe around the robots.
Hello everyone, my name is Sándor. I work at MMBIL. We provide electronic engineering services for more than a decade now. We responded to an open call from Stucky showing interest in cooperation with SMEs in Hungary. So in the 5G-SEDAR, we designed a small electronic device which collects and feeds all sensor data required for the AI-assisted manufacturing experiments. This is a novel approach in the robotics area. It is a battery-operated, completely wireless device, so it's really easy to mount to a robotic arm. There are no cablings, only the mechanical adapter shall be fixed. And this device provides multiple camera feeds along with many other sensor data which is required to develop cutting-edge robotic applications. So this is the device mounted on a robotic arm. As you can see here, the only cable which is now running here is related to the gripper. So our device doesn't have any cabling at all.